Welcome back. We're going to enter into section 6.7 today. And section 6.7 is titled Recursively, which is a big word. We'll talk about what it means. Recursively defined sequences. Okay? And like I said in class, it's not the ideas aren't any different from section 6.6. It's just how we're going to write them. Okay, so let's just start here off with it, example 1. Okay, and on example 1, let's say I gave you the sequence of 2, 6, 10, 14, so on and so forth. Okay, so I'm hoping that you see that the difference here is, well, you add 4, you add 4, you add 4. And so we can describe this sequence as arithmetic. Okay, and so then we could use the arithmetic equation of a sub 1 plus the quantity n minus 1 times the difference. So a sub 1 is 2 plus n minus 1, the difference is 4. So we have a sub n equals 2 plus 4n minus 4, which then gives you 4n minus 2. Okay, so that's what 6.6 was about. Okay, and I just want to talk about, well, two things. First of all, this is called an explicit rule. So I'm explicitly saying to you to find the 10th term, you take 10, you multiply it by 4, and then you subtract 2. Okay. The second thing we need to talk about is we need to talk about this notation. Okay. So these right here, even though they have values, we said that this was a sub n, and then n is the position of each term. So the first term is 2, the second term is 6, the third term is 10. The fourth term is 14. And so you actually think of these as your n are your x's. Okay, so like 1, 2, 3, 4. And your y values are the actual value of the term. Okay, and the reason that that's really important is because the notation we're going to use today is going to require you to understand what n is versus a sub n. So n is the position, a sub n is the value. Okay? And so now let's go back to this thought here. So you've got a sub n equals 4n minus 2. We could also describe this sequence here as something a little bit different. We could also say, well, a sub n is equal to whatever you have before it plus 4, right? It's like it's saying take the term before, add 4. Take the term before, add 4. Take that term, add 4, right? And so that idea of taking what you have and adding, or taking what you have and doing something to it, is called recursion. It's also called a loop, okay, if you are familiar with computer science terms. So the thing about recursion is that it has a different formula. So what we say is we say, okay, take the term before, and we say that's a sub n minus 1, because a sub n is the term we're on. So a sub n minus 1 is the term before. Okay, the term before. So take the term before, and we're going to add 4. Okay, that is a recursive rule. So anytime that you have an a sub n minus 1, that's talking about an idea of recursion. It's basically saying take the term before, add 4. Okay, and we can have these for geometric or arithmetic. So just real quick, if you've got a sub n equals a sub 1 times r to the n minus 1, right? That's what we had with geometric. Then the recursion of that would be, well, okay, take whatever the term before it was and multiply it by the ratio. So this is the explicit rule. This is the recursive rule. Okay? So that's the idea of where we're going. The concepts are the same, just kind of how we write them. So let's go ahead with that knowledge and let's do example 2. Okay? And in example 2, let's write the first 4 terms of, well, let's see, if a sub 1 equals 3, and the rule is a sub n equals 1/2 of a sub n minus 1. So we're given the recursive rule. Okay, so let's just start with, well, we know that a sub 1 is 3, right? Okay, so if we want to write the second one, we go to this rule and we say, okay, well, a sub 2 equals 1/2 of a sub, the n is now 2, and we subtract 1. And so that's the same thing as saying 1/2 of a sub 1. Well, a sub 1 we already know is 3. That's why a sub n minus 1 means the term before, okay? You don't have to show me these 2 steps every single time, but that is why we use a sub n minus 1 to mean the term before, okay? So 1/2 of 3, well, I'm going to keep that as 3/2, okay? So the second term of this sequence would be 3/2. And then we go to a sub 3, and a sub 3 is 1/2 of the term before. 1/2, not 1/3, sorry. So that's 1/2 of 3/2, which then gives you 3/4, right? And then the fourth term would be 1/2 of the term before, which is 3/4. So you get 3/8. So the first 4 terms are 3, 3/2, 3/4, 3/8. And you could continue if you wanted to, but they only want you to find the first 4, so don't get too crazy. Okay. Okay, pretty simple, pretty straightforward. Let's look at another example. We'll call this example 3. Okay? And here on example 3, the directions are going to say, write a recursive rule for, and we're going to do 2, okay? The first one we're going to do is -30, comma, -18, comma, -6, +6, and 8. And the second one we're going to do is 500, 100, 20, 4, and 0.8. Okay? So those are the 2 we're going to look at. The first thing you have to realize is, well, what is the pattern? Are we arithmetic or geometric? Because that's going to determine which one of the formulas that we use. Okay? So right here, we've got -30 to -18, -18 to -6, -6 to 6, and then 6, sorry, this should be 18, 6 to 18. Okay, so I'm hoping that you see that you add 12 each time. You add 12, you add 12, okay? So this is an arithmetic, okay? So that means that we're going to have a sub n equals a sub n minus 1 plus 12. That's literally it, you guys. You take what you have before, you add 12. The only other thing that we have to do is we have to define the first term. You have to explicitly write what the first term is. You must have both of those pieces of information. Here's why. Okay? So I'm going to come over here and then I'm going to go back to that other example. Here's why. Let's say you had a sub n is equal to a sub n minus 1 plus 2. Okay? And I didn't tell you what the first term was. So let's just say that you thought the first term was 1. So if you thought the first term was 1, well, then a sub 2 is 1 plus 2, which is 3. And a sub 3 is 3 plus 2, which is 5. Well, what if your neighbor thought that the first term was 4? Because I didn't tell you, so if I don't tell you, it can be anything you want. So, well, then a sub 2 is 4 plus 2, which is 6. And a sub 3 is 6 plus 2, which is 8. And those two things are completely different. So you must define where you start. And if you don't define where you start, I will be taking off points. Okay? Back here. All right, I'm hoping that you see this time that this is going to be geometric, okay, because it's decreasing pretty heavily. And so I've had some questions on, well, what if I can't see the ratio? What if I don't know what the ratio is? Okay. And so my advice to you is, well, if you don't know what the ratio is, you can always try to find the ratio by working backwards. So, like, because this is going downward. So, what if you tried 100 divided by 500? Because you know that you're going multiplication going forward. So, okay, so that's 0.2. All right. So, okay, well, would that be the same if we did 20 divided by 100 and got 0.2? So that means, okay, well, then if we go forward, 500 times 0.2 is 100, times 0.2 is 20. So you can work backwards to find your ratio, okay? And so this is geometric, so our recursive rule is a sub n equals the ratio, which we just decided was 0.2, or 1/5, if you prefer fractions, okay? 0.2 times the term before, which is a sub n minus 1. And then we define our first term as 500. Okay? Beautiful. Great. Moving on. Example 4. All right, in example 4, we are going to write an explicit rule for, and then if I tell you a sub 1 equals 25 and a sub n equals a sub n minus 1 minus 10. So I've given you a recursive rule, and I need you to give me the explicit rule, okay? So again, the first thing you need to consider is, well, is this even arithmetic or geometric? Okay, and I need you to understand that if it's geometric, it will have a multiplication factor. If it is arithmetic, it will be, if it's arithmetic, it'll be going up or down by addition or subtraction. Okay, so since we have a subtraction here, we have an arithmetic situation. Okay, so an arithmetic explicit rule looks like a sub n equals a sub n, or a sub 1 plus n minus 1 times the difference. Okay. And so a sub n equals a sub 1, which they gave to you as 25, plus n minus 1 times the difference, which is negative 10. So we have a sub n equals 25 plus negative 10 times n is negative 10n plus 10. And then we clean that up and we say a sub n equals 35 minus 10n. Okay? So that's just moving from one rule to the other. And similarly, we can go the other way as well. Okay, so this is example 5. All right. On example 5, we are going to write a recursive rule for, okay, and I'm going to give you a sub n equals negative 3 times 2 to the n minus 1, okay? So the first thing that you need to understand is that right there is the ratio. And then from what we learned in section 6.6 is that right there is your first term. That's when n equals 1. So if we're going to write a recursive rule here, well, we need to say a sub n equals the ratio, which is 2, times the term before, which is a sub n minus 1. And then we must define our first term, but that equation gives us our first term of negative 3. So writing recursion rules from explicit rules is actually pretty easy. You have to do some additional work if you go from recursion to explicit, but if you're given explicit and you need to go to recursive, you just have to, look at the ratio or the difference and then define what the first term is. Okay? Nothing too crazy. Okay, the thing about recursion that's really awesome, I've got one more example for us here in example 6. The thing about recursion that is super awesome is that you can use recursion even if it's not arithmetic or geometric, okay, which is awesome. That's really great. And so what if I gave you this sequence? And we talked about it in class already. It's called the Fibonacci sequence. 1, 1, 2, 3, 5, 8, 13, so on and so forth. It's where you take the two previous numbers and you add them together. So like 1 plus 1 is 2. 1 plus 2 is 3. 2 plus 3 is 5. 5 plus 3 is 8. 8 plus 5 is 13. Okay? So that's the pattern. And so what we have to figure out is how we can mathematically write down that pattern. Okay? So let's just start with saying this. Let's look at the third term. Now I just picked the third term out of thin air because I know what this rule looks like, and so I'm trying to help you get there. Okay? The third term, which is 2, was taken by adding 1 plus 1, right? Well, these were the first term and the second term, right? Okay, so what about the fourth term? The fourth term, which is 3, was taken by adding 2 and 1, right? So 1 plus 2, which was the second term plus the third term. And the fifth term, which is 5, was taken by adding 2 plus 3, which was the third term plus the fourth term. So what we've got is okay, well, if we want to find the third term, we add the first and the second. If we want to find the fourth term, we add the second and the third. If we want to find the fifth term, we add the third and the fourth. So if we want to find the nth term, we're going to add the 2 terms before it. And we know that the term before is n minus 1. But if you want the term before the term before, so 2 before, well, you write that as a sub n minus 2. And then, of course, define your first term as 1, right? So that is how you write a recursion rule for the Fibonacci sequence. So you can actually write recursion rules for a lot of different sequences. So now they don't even have to be geometric or arithmetic. You can write them for Fibonacci. You can write them for several others as well. And so that's why recursion rules are necessary because, we can have rules for geometric and for arithmetic, but what if it's not neither of one of those? How are we going to define it? How are we going to write it so we can find, the 100th term? And the answer is recursion. Okay? So hopefully that made some sense. You'll have a lot of time in class to ask all the questions you want. So write them down, and I'll see you later.